right, welcome to this video. So we're continuing with the integration of volume of solids. So this is the question that comes from the further studies paper from 2021. So this is question 12, and let's see what was being asked. There you're given the area bounded by the curve at f of x is tan of x, where x starts at 0. So we know that our lower boundary is 0. And our upper boundary is a, and a is less than pi over 2 rotated about the axis. So what we then have to do is give an expression for the volume in terms of a. Well, this question then becomes a little bit simpler to do because the formula is given to us in the formula sheet in further studies. So let us dive right into it. So the way we will do this, we'll get the volume, and this is going to be pi over our lower boundary, which is 0, and our upper boundary, which is a. So we have to write the volume in terms of a. And then we just need to square our function. So this is tan of x, and all that we have to do is simply square that. And we just need to solve for our volume. So going about this is a. This is now the tan squared of a dx. And I think you'll remember now that in this case, we don't have a specific integral for this, but because of this, this is indeed one of the identities that are given to us in our formula sheet. And I think you can remember from here or use your formula sheet that tan squared is merely sec squared x minus 1. So please ensure that you remember that and you use that. And then from here, we can continue in saying that this will be the integral going from 0 to a of sec squared of x minus 1, everything at dx. And then we can now easily get the integral of sec squared, which is going to be just the tan x, and the integral of minus 1 will just be minus x, and then we'll apply our boundaries to this. So from here, we're happy to get that if we use our boundaries, this will then be the tan of a minus a, and then minus that, this will be the tan of 0 minus 0. And I'm sure that you've guessed it right, that this whole expression over here equals to 0. And therefore, the volume in terms of a will just merely be pi tan of a minus a. And then we are done with this particular question, and this will be an expression. And because we're finding volume, just remember that it is units cubed. I will try to do some more questions as I'll be dealing with more past paper questions involved in this. But I think we now understand the concept of volume, and we shall see it in more videos to come. I hope this has made sense, and I'll continue to do all the other topics in further studies. So make sure that you like and subscribe.